Today's lesson is part 1 of our electricity and magnetism lesson. The due date for all periods is going to be on Friday, March 7th. Make sure you take good notes and are ready for your quiz. So far we've talked about electricity and magnetism in this unit. Electricity, we talked about electric charges and currents. Magnetism, we dealt with the properties of magnets. Now what you want to think about, there is actually the combination of these two, is called the study of electromagnetism. So you can probably see pretty easily, here's our electricity part and here is our magnetism part. So together we make electromagnetism. So anytime we talk about how electricity and magnetism are related, because they are in fact related, this is the term that we use. We're going to talk about a new situation in which electricity, or in this case currents, are related to magnets, or in this case magnetic fields. Now a current, remember, is the movement of electric charges as they go through a wire. And what you need to know is that as we have electricity going through our wire, as we have a current, remember our symbol for current is I. As we have a current moving through a wire, it's going to actually create a magnetic field around it. So, for example, what it's going to end up looking like, you'll end up with circles going around this magnetic field. So it'll have bigger and bigger circles going around, and it's all along the entire wire will you have circles going around. So there's a magnetic field where if you were to put a compass or a magnet next to this wire, it would actually be affected by the wire. Just so you know, this is a 3D image, alright? So if I were to look at this from kind of this view right here, for example, if I put an eye right here, look at this view, what I would end up seeing is here's my wire, and then around it I would have magnetic fields going like this, in this direction. Okay, there we go. You'll notice in that situation that I did actually have the magnetic field going in a specific direction. So let's say that I have a wire and that the current is going to the right. In order to figure out which way the magnetic field goes, what you need to do is you need to take your right hand, sorry, this is a little difficult, take your right hand, and your thumb should point in the same direction as the current. Remember, right hand rule, really important for you to practice, really important for you to know when to apply it. So have your thumb facing towards the current, and then once you do that, the way that your fingers curl will show you the direction of the magnetic field circles. So in this case, we can kind of see that these are going to wrap around above the wire and then go under. So I would go ahead and I would draw this starting behind, coming over, and then going back. So these are what all of our magnetic fields around the current are going to look like. And remember, there are even bigger circles around it, even bigger circles around it. So we need to now talk about the strength of the field around a current. So we're going to go ahead and talk about a new equation, and the new equation is B, remember B stands for magnetic field, equals mu, this is a weird looking letter, it kind of looks like a U, kind of looks like an M, I don't really know, but it's called mu, and believe it or not, it's spelled with an M and a U. So mu times the current, right, this entire thing is mu, just FYI, so this little thing, don't worry about that, but mu times the current, I, all divided by 2 pi times the radius of the wire. So R stands for the radius of the wire. So imagine if I was looking kind of, here's my wire, like this. The radius of the wire would be from the center of it all the way to the edge of it. That's R right there. Really quickly, we need to talk about mu. It stands for 1.257 times 10 to the negative 6th. It's kind of a crazy number, but what it looks like if we were to go ahead and take it out of scientific notation, we'd take 1.257, move that decimal 1, 2, 3, 4, 5, 6 times to the left, and put a point there. So I'd have 0, 0, 0, 0, 0. So 0.0000001, and then I erase this one right here, 1275. So for those of you that have calculators, it might be a little bit easier for you to do this, but just know that you would have to put it in standard notation if you don't have a calculator, or if you're using your phone. So 0.00001257. And then don't forget that pi stands for 3.14. So those are two things that we need to know about this equation. So let's do a really quick example together. A wire that has a radius 0.0035 meters has a current of 4 amperes. What is the strength of the magnetic field around the wire? So radius, all right, this is going to stand for R in my equation right here. We can see that we have amperes. Remember, amperes tells me that that is our current, or I, in our equation. And we are being asked for the strength of the magnetic field, which is B. So B is what I am solving for right here. So if I go ahead and I plug everything in, B I leave as a variable, equals, remember mu is all the way up here, this crazy number right here, so 0.00001257, times the current, which we have right here, so times 4 amperes, all divided by 2 times, remember that pi is 3.14, so times 3.14, times our radius of the wire, which was 0.0035 meters. So remember that whenever we see some setup like this, technically there are parentheses on the top and there are parentheses on the bottom. So we should start out by solving this inside the parentheses, solving this inside the parentheses, and then we should divide. So let's go ahead. If we multiply all of the top parts together, we would end up getting 0.000005. And if I multiply the bottom parts together, I'll end up getting 0.02198. So then I plug those back into my equation. So on the top, again, I will have this number. So go ahead and do 0.000005 divided by the one on the bottom right here. So 0.02198. When I do that, I should end up getting divided by, so I should end up getting 0.000229. And remember, units for magnetic field are Teslas. So this is my answer right here. That's it for today. Make sure you took good notes. Make sure that you practice. See you guys later.